In today's episode, we'll investigate the effect of electricity on plant growth. We'll conduct a simple gardening experiment on electroculture and see what happens to plant growth when plants are exposed to a low DC voltage. That's coming up. This experiment is based on two observations. 1. Plants often appear healthier after a thunderstorm, possibly due to the effects of lightning and electricity. 2. Plants growing near an electric power cable tend to look greener and healthier. Now, let's conduct this experiment, starting with our hypothesis. Seeds germinate faster and plants grow faster and healthier when exposed to a low-voltage DC current. I came across many research articles online on electroculture. According to the electroculture technique, plants are sensitive to electricity and magnetism, which can lead to improved plant growth and increased yields. This technology may even help protect plants from pests and diseases. As for the mechanism of action, I couldn't find convincing explanations. It might involve the copper electrodes causing electrolysis or electrophoresis, releasing copper and other salt ions into the soil, or the electromagnetic field from the electric current causing different ions to move into the roots. Now, let's jump into the experiment. Starting with the materials and methods. Materials required for the experiment. 3 plastic containers. Identical plant seeds for all 3 containers. Identical potting mix for all 3 containers. A 9V DC battery, a 3V DC battery. Copper rods or copper wires as electrodes, a ruler or measuring tape. Procedure. Label the 3 containers. Pots. A and B are for the experiment, and pot C will be the control with no current applied. Identical factors. Fill all 3 containers with the same potting mix or soil. Plant the same seeds in all 3 containers, place them in the same location to receive the same light, and water them with the same amount at the same time. Prepare the circuit. For pot A, we'll use the 3V battery, and for pot B, we'll use the 9V battery. Copper wires will serve as electrodes inserted into the soil. Sow the seeds. Plant the identical seeds in all 3 containers at the same time. Sow the same amount of seeds in each container and water them equally. Place all 3 pots in the same location, like on a windowsill. Apply electric current to pots A and B. Insert 2 copper rods into the soil on opposite sides of each pot, ensuring they don't touch. Connect the 3V battery to pot A and the 9V battery to pot B. Turn on the circuit for 15 minutes daily and measure plant growth on day 4 for seed germination, then on day 7, day 12, day 15, and so on. Results of this experiment. Day 4. As you can see, seeds in pot C, which receive no voltage, are germinating first. In pot A, 1 seed has germinated, while pot B shows no definitive signs of germination. It's possible that the higher voltage in pot B is affecting soil organisms negatively, as indicated by an earthworm struggling to survive. Day 7. The plants in pot A are still shorter compared to those in the control pot C. Pot B, which received 9V, is just starting to germinate. So as of day 7, this electroculture theory seems to be disproved. I'm unsure why, and this experiment may require further investigation. I'll provide an update on this experiment on day 15. We could also repeat it using different DC voltages like 1.5V, 6V, or even 12V, or by altering the exposure time to the current to see how plant growth is affected. In our next episode, we'll conduct a similar experiment to study the effect of magnetism on plant growth and seed germination. Please let me know in the comments below if you have any thoughts on this experiment. If you found this helpful, give it a thumbs up, share this video with friends, and if you're new to the channel, consider subscribing. Happy gardening!